Our next speaker is Sophie Pennetier from Enclose. Sophie holds 15 years of experience in the design of complex structures and facades. With Enclose since 2018, she has steered select sales and design assist scopes and R&D topics, including ultra-thin glass, acoustics, and embodied carbon. Her prior experience includes Arup in New York, Shop Construction, and RFR in Paris. In 2010, through the Industry Academia Partnership, IAPP-RRC, she developed cold bend glass analysis tools. Sophie, there you are.
I'm sorry
Sophie
for that.
authored several papers on structural glass and has been involved with the development of US glass codes with ASTM, Journal of Architectural Engineering, as associate editor, and in 2021 joined FTI's board of directors. The floor is yours.
I had no idea you'd have to read it all. I would have made it shorter and sweeter. Do we have a timer here? Okay, timer's here. All right, well, thank you all for joining my presentation. It's a hard act to follow after Agnes. I'm not going to give you the details of my FE model at all, but I'll keep you on schedule. That's the sweet part of my presentation. So I'm going to talk about this art installation in New York City in front of the Stock Exchange of Wall Street. If you want a lot of details, you can go into our paper. We're going to mostly show project pictures now. And you can feel free to leave if you need to go to the next session. So we installed this project in New York City with my friends that reached out at the end of 2020. We had worked together prior to that on the US Olympic Museum and the adjacent bridge. So actually most of what I do until that moment is still structure, even though I come to those glass events. And so we established our friendship and trust throughout those real world projects. And the Olympic Museum, and we ourselves become lifetime Olympians. So through this experience, we again developed this collective that we are. We've done various installations related to social issues, environmental issues, and this one is about the broken ceiling. So for non-native English speakers like me, a broken ceiling represents this kind of distance from a space that you cannot go, and typically, is in used for diversity accesses to places where they have been absent before. And specifically for this one, the work was commissioned by State Street advisors in Wall Street, in order to celebrate the broken glass ceiling of Kamala Harris accessing to the second highest office in the US. Our design started in the last days of 2020, and after our design session on January 6, 2021, the client decided that it was a little too political to celebrate Kamala Harris, so we moved this event to Women's International Day to represent like the larger concern. So that's a bit of context for this. So broken ceiling, the architects did a lot of experiments. I forgot to name them, Mirka May, Jensen, Yoshiro Okamoto, and Ryan Butts, and we'll talk about the rest of the team in a second. Did a lot of experiments with broken glass. But obviously we could not put like real broken glass in the streets of New York City, especially given the context in the US. So what we ended up doing is, again, architects leading the design here, playing with shadow cast by the edge of the glass, and looking at represent the splash of glass, this moment at which the glass ceiling is broken. So those kind of like bouncing moments are typically illustrated by those kickstands that are these slanted glass pieces surrounding what I failed to mention until now, the Fearless Girl. The Fearless Girl is this statue in front of the stock exchange that we'll see in a second, and she is representing, change, fearless change. And so those kickstands, before I move to the next slides, we're talking about this a little later. So for nomenclature, we have the slanted pieces, the board, and I'll talk about the kickstands, the stands themselves, which keep them propped up. They are linked and connected by clear structural adhesive, UV cured adhesive in this instance. So it's an external application. We had only a 2-day installation, so 2 days only allowed us to be confident about this application viability, which should be questioned for other longer exterior applications. So that's the site, Wall Street on the left and Bond Street, and this is where the New York Stock Exchange is. It gives you a bit of a sense of scale of, again, the Fearless Girl statue and the broken glass ceiling all around her. They are, so you see the pieces are as tall as human size. Fearless Girl, she's a little short. And they are 350 pieces or in excess of. So there are pieces that are flat on the ground and pieces that are standing up. And I already had my first question earlier by Jens, was it actually broken glass? And the answer is no, it was not. And that's very relevant as we're talking a lot about circularity and things of that nature. But in this specific art installation, which is also very important for humankind, we had the glass, cut from new sheets of glass, right? So yeah, here are the pieces. On the bottom, the flat parts, and up top the kickstands and their little kicker. And in the bottom here, you can see the source of those pieces is out of 1.5 jumbo, completely new pieces of glass. There was no shop drawing. We had no time, no money. So the process of, before I go there, a few more pictures of axonometric and the render that got us validated for the design. So you can also see that it was the only project where I was really the architect questioned the use of low iron. I'm not used to this. We had this discussion and we went into more blue, more clear. Well, I definitely changed the slides. So these are the kickstands. They're angled at up to 45 degrees, and some are much shallower. As you can see, this is the more tilted up, the more down. And what you can observe is, after the VME process, we actually integrated some little pads to make sure that the roughness of moving these things around the pavers of Bond Street, Wall Street, would not affect the edge of the glass. I'd like to talk about process. So there was no shop drawings, but also there was a very, very limited engineering backloop with, architects making a geometry, and then the architect and the engineers modeling it up. So what we did was to equip the architect with a toolbox. So instead of the typical, can I do that? No, try again. We just gave them the script. So this is the Grasshopper script that checks very basic stability conditions. So we gave multiple directions of loading. So you see here in sub-quadrants. And basically, super basic, made the sum of loads applied and making sure things are stable, right? So if you got a little green apple there, you're stable, no problem, all good. If you're in the unstable condition, for instance, if you go in and out of the screen here, you got a big red dot, it is not stable. You have a risk of overturning. So that is the tool that we equipped the architect with, and they massaged the geometry. So I have a little animation here. If you mind starting a video. Dear, okay, thank you. Yeah, resolution is funny. But you see here the bottom cursor, and we also changed the kickstands. So these generate if we can replay just one last time, the conditions of testing the geometry for every overturning situation. So super simple, but this is the architect, so we give more work to the architects. That's wonderful. Works with me. Less work, but we keep on the focus. Next one, please. I guess I can do this. Right, one last moment. So these were just stability. Perfect, thank you. It's just stability checks. And that brought us in the right ballpark of stability. I failed to mention the loads. We're in the streets of Manhattan. So we're not on the waterfront, not like high windows. And we also have a 2-day event, like extremely short return periods, which allows you to have smaller loads. Fantastic. So for this load conditions, we designed for 40 mph, so that's about 60 kilometers per hour, and some little kick load of, I think it's 2-3 pounds in every direction, so that's what we designed for. So that was the overturning. And then once things were roughly stable, I brought those things into Strand to accurately model the stiffness of the bonding, the softness actually of the bonding, and generate the right check of stress in the glass. So your typical FE analysis. Oh yeah, and that's again the joint, the adhesive joint that we incorporated. So I don't know if I mentioned it already. Well, it was Dimax 429. You can find a bit more information on the paper. It was also the moment that I moved from R2 to R3, and I don't know if people have experienced this moment, but this is where you used to really segregate which panels you want to check, like really be more mindful about which panels you're going to spend your hours of modeling into, like really heavy running and the meshing, etc. And I had the hotline of Strand, who's always there when we need them, and they were like, oh no, just switch to R3, dump all of your models into there and just hit run. So the auto meshing and just the running of my model was extremely short, so in the end we ended up modeling everything. And I just started to say we, because that's the moment that we too brought Michael on board. So we were gonna put this exhibition in the streets of New York, so obviously we were going to be liable for it, and who wants to be liable for it? So Michael is. So not only did it help Agnes before us, but he helped us as well, reviewing the process, the modeling, and the adequate changes related to his review. So he's here if you have hard questions that I cannot answer. So yeah, I say no shop drawings. So basically our delivery process to the fabricator, who I forgot to mention and need to mention right now, was Agnora. So Agnora, Louis is here at this time, has graciously been contracted to cut the glass and educated us, the whole design team, throughout the process of necessary tweaks for fabrication, but also their fabrication process. So there was no shop drawings again. Our delivery process was just a really big Excel spreadsheet. So we're very grateful for Agnor, who has been immensely patient through the process, but also helped us understand their process, their equipment, and have a bit of a shortcut through fabrication. Again, it's an art piece, so worst case, we're not too bad. So these are a few pictures from the manufacturing by Agnora. Again, it's 2021. We're still mostly at home, locked down. So all the factory visits, everything was remote. Everybody was at home in their pajamas, so it was pretty convenient. But also the trust. Well, not everybody. Agnora was actually on the ground, but the trust with Agnora enabled us to just. We didn't go there. We didn't have to go there, and it just showed to the assembly floor on time. So we're very grateful for it. Assembly floor is the new motor in New York City. So this is an installation production company. They do little pop-up exhibitions. It was the first time they ever did glass assembly. So there was a lot of education process throughout their first use of UV cured adhesive. So here's their shop where you can see the installation of the adhesive and subsequent curing. And there's a video on the right, if you can play it, under the right image, if you can listen to me. Yep, thank you. So yeah, the test was extremely professional, consisted in just like sandbags into our joint after adequate curing, and so we were able to verify, the strength of the adhesive bonding, and we also showed this to the client. So Michael, actually, you took this video, and we were able to reassure them of putting this glass in the streets of New York was something that we understood, that we designed for, and we knew what to expect. So that was a great moment during the VMU process of like showing the VMU and the testing to the clients, so they really know what to expect. My timer left, so maybe I'm out of time. That's the shipping and assembly to the new motor. I'll try to wrap up quick. Okay, thank you. 3 minutes. And so the installation on site, this is Merica here, was trying to draw from curtain wall layouts and grids and the like. And so we were. It was quite hard actually to place every of those transparent pieces and on the ground without those lines. And as you can see, like any elevation, would be quite difficult to represent exactly where everything is. When you have a base of a place, you actually have to go tuck under an existing part. So what I brought on site, and it's probably not the best video, but that gives you the concept, is if you can play the video again, thank you. That's AR. So again, this is the intended 3D geometry, and of course the architect moved everything again. We had to squeeze our installation a little bit, but the goal was to say, all right, when you have things that are transparent and in line with each other, it's very difficult to actually represent it in elevations again. So the use of AR allowed us to say, like, where's 42? We were able to locate and shift around pieces so that we were having the adequate QC and installation staging. Yeah. All right, next. Come on. Yeah, things are shifting a little bit. It's a sloped. Yeah, please go ahead. Yeah. All right, so that's the installation as we finished it. It was exhibited for 2 days, and if we move to the next couple slides, there's a quick video that you can play if you wish. Big shout out to Agnora, again, the new motor, and all people involved into this process for this very beautiful work we're very proud of. Thank you.